Hello everyone, I hope you all are fine and preparing well not only for your class 12th board examination but also for the competitive examination. Dear student, differentiability is a very important topic of mathematics. So just pay more and more attention on this topic, and today we are going to discuss one more topic, that is higher order derivative of differentiability. In this video, I'll discuss with you the meaning of the higher order derivative as well as its notation and few of the example to give you an idea how to solve such kind of question. So let's start. First of all, let's start with the meaning of higher order derivative. If a function is in the form y equals to fx, okay, fx is differentiable, so on differentiating y with respect to x, what are you going to get? You will get y dy upon dx and d over dx of fx. So d over dx of fx can also be written as f dash x. You have already studied all these things in class 11th as well as in class 12th. So this notation you all are familiar with, but you were not familiar with the name, that is, this is known as first order derivative. Okay, you are familiar with this, but you are not familiar that this is called the first order derivative. Okay, so first order derivative is represented in this form. So if we talk about the higher order derivative, then how to solve it? If you are having this in your hand and f dash x is also differentiable, then in that case we are again differentiating this dy upon dx with respect to x. So if we do so, then dy upon dx will become d2y upon dx2. As you are differentiating it second time, that's why here it was only dy upon dx d1. We are not using 1 here, dy upon dx. As we are doing it second time, so we are going to write d2y upon dx2, and in place of here we are going to write d over dx of f dash x, and finally we will use f double dash x. Double dash, that's why we call it second order derivative. Okay, so if you want to write for the third order derivative, then it is very simple. You will write d3y upon dx3. This is equivalent to, you can write d upon dx of f double dash x, and this is equivalent to f triple dash x. Okay, so if you want to write the fourth or the nth, then also you can write it so easily. So this is how we write, okay, the higher order derivative. Now let's talk about the notation. We use many notation for higher order derivative. Just see, pay attention. You can write dy upon dx for the first order derivative, or you can write f dash x that you have already studied. In place of that, we can also write sometimes y1. 1 represents the first order derivative. We can also use capital D y, that is also the representation, and we can also use y dash because our function is y equals to fx. So when we differentiate it, so we can also write it y dash. Okay, if you talk about the second order derivative, then in place of dy upon dx we write d2y upon dx2. In place of f dash we write f double dash x. In place of y1, y2. In place of dy we write d2y. Okay, d2y means second order derivative, and y dash, that is y double dash. Similarly, we can write other higher order derivatives. So it's very easy. Now let's talk about an example, that is very easy question. So what is that? Find second order derivative of x square plus 3x plus 2. Very simple. First of all, you write let y equals to x square plus 3x plus 2. You want to calculate the second order derivative. It means you want to calculate f double dash. So first of all, we are going to find out only f dash. So differentiate it with respect to x. So you will get dy upon dx and then d over dx of this expression. So x square means, first of all, you are going to use the algebra. So d over dx, this will become d over dx of x square plus d over dx of 3x plus d over dx of 2. Okay, d over dx of constant function is 0, d over dx of 3x is 3, and d over dx of x square is 2x. So finally we are going to get this. Okay, now this is a polynomial function and differentiable, so we are again going to differentiate it. So if we are going to redifferentiate, then we will get, in place of dy upon dx, d2y upon dx2, and in place of 2x plus 3, it means what are we going to do? D over dx of 2x plus 3. So again you are going to use the algebra, so d over dx of 2x first of all, so and plus d over dx of 3. So d over dx of a constant function 3, that will be 0, and d over dx of 2x will give you 2. So this is what your answer in this case. Okay. Now you see the second example. It means the first question was very easy. Now you see the second example. What is that second example? The function is in the form, find the second order derivative of x cube log x. Okay, obviously two functions are multiplying in this question, so let's see how to solve it. Let y equals to this. Now differentiate it with respect to x, so we will get this expression. Now obviously two functions are multiplied, so we have to use the product rule. What is our product rule? D over dx of uv, that give you u v dash v u dash. Okay, so this is what we are going to use here. So this will give you x cube d over dx of log x plus log x d over dx of x cube. Very easy, we have simply applied the product rule. Now x cube as it is, and d over dx of log x, we know the formula, that is 1 upon x plus log x, and d over dx of x cube will give you 3x square. So one of the x will be cancelled here, so you will get x square plus 3x square log x. So this is the value of dy upon dx. As you want to calculate the second order derivative, so it means we want to calculate d2y upon dx too. So let's see in the next slide. Now you see, this is what we got in that slide. So now d2y upon dx2, it means d over dx of this expression. So again algebra, apply algebra, so d over dx of x square plus d over dx of this function. Okay, now d over dx of x square will give you 2x, and this is again the multiplication of two functions, so we are going to use the product rule. Take 3 outside. First of all, x square as it is, d over dx of log x, then log x plus log x as it is, and d over dx of x square. Now d2y upon dx2 equals to, this is 2x, and this will give you, what is d over dx of log x, that is 1 upon x, and log x d over dx of x square 2x. One of the x will be cancelled here, so this will give you 2x plus 3x, and plus this 3 will be multiplied with this 2, so this will give you 6x log x. Now both will be added, so this will give you 5x plus 6x log x. Take x common, then the final answer will be x common 5 plus 6 log x. The question is very simple. Again I'll advise you, if you are looking only at the question, you will find it little tough, okay, and chaotic. But if you are going to solve it in your copy, then you will find that it is very easy, very simple. So again I will advise you that mathematics is not a subject that you watch and entertain. It is a subject of practice. So you just open your copy and do many of the question, and then only you can have the command on this topic, and it's very, very important topic for you. So if you have any query related to this topic, you can post it to me. Thank you very much.